Welcome back for part 2 of chapter 3, section 8. That's a lot of numbers, multiplying and dividing rational numbers. Here we're going to step up our game a little bit. You can see in this problem we've got it set up algebraically with 1/2 times 4 times y times x. But the kicker comes that they've mixed in some decimals and they've mixed in some fractions in here. Now, first question we need to ask ourselves in doing this: can we work these all as fractions? Can we work these all as decimals? Can we convert everything to a decimal? Well, looking at it, I got a 4. The factors of 4 are 2 times 2. And I got a 5 in the denominator. That's 5. So all of my denominators are either 2's or 5's. And what does that tell us? That tells us that yes, indeed, we can convert all of these to decimals, which may be a good way to work on these. And I suspect it's going to be the way the textbook wants to do it. So let's get started. As you can see, the textbook is saying exactly what I said about how we need to find out whether or not the fractions can be changed into terminating decimals, which they can, and they're going to go ahead and move that direction with it, I think. You can see they've got the original expression here, 1/4 times x times y times z. From there, you took 1/4 times, what was my x value? Well, my x value was, well, I don't know, let's show the problem down here. My x value was 9.5, so we're going to do 9.5 right here, times y times z. Check that part, that checked good. And then the z part, 2 and 1/5 written as a fraction, well, that is going to end up being, as written as a decimal, that is going to end up being 2.2. And check that, and that part checks right. And of course, 1/5, that's the same thing as 2/10, and 2/10 you can see right here, 2 and 2/10. That's where I got that number from. Next thing we're going to do is just flat out multiply, and it's not going to be a lot of fun multiplying all those decimals, but when you do multiply all your decimals, you get 4 and 1800ths. A positive times a positive is a positive. A positive times a negative is a negative. A negative times a positive is a negative. So our final answer is going to be -4 and 1800ths that you see right here. No reason to type it in off to the right there because they already gave us what the answer is. And now it's going to be your turn to pause the video and work this problem on your own. R times S times T, where R is -5.1. S is going to be -3 1/8, and Z is going to be, I'm thinking that Z is supposed to be a T right there, so we're going to pretend that Z is actually a T, and that is going to be -4/5. Go ahead and pause the video and work the problem. Alright, so I have taken and written my problem out. Multiplying R times S times, we're going to call ZT. Not my fault. I didn't create the lesson. And then I'm going to notice the fact that my fractions, this one is 2 times 2 times 2 equals 8, and that's a 5. 2's and 5's means that you do get a terminating decimal. And since we get a terminating decimal, we're going to go ahead and convert everything to decimals because I think that's what the textbook wants. If it was me doing it, honestly, I would end up doing everything as fractions because fractions are cool, fractions are your friends, but they didn't ask my opinion on this one. So right here, we're going to have -3 and 1/8. That is 1 divided by 8 is 0.125, or, I'm sorry, I put a decimal where it didn't belong, 25. And of course we don't have 0 for this one, we have the 3, so it's 3.125. And then 4/5, well, 4/5 is the same thing as 8/10, and 8/10 is the same thing as 0.8. So there's all of our decimal points, how we would plug them in. And we're going to go ahead and just save y'all some time and grab that handy dandy pocket Satan to work this out. 5.1 times 3.125 times 0.8 equals, so we have 2.5 over here as our decimal answer. But we also need to pay attention to our sign. Negative times a negative is a positive. Positive times a negative gives me a -2.5. I'm going to come back to my book here. I'm going to type in a -2.5 accept, and check our answer. Why are they saying it's wrong? Did they really? Oh, 2 3/4. Wonder what I did wrong. I'll have to check my work on that one. Yes, I clearly mistyped something there because it is 12.75, and look at this. Even though they gave us a problem where I thought they wanted us to find the fraction or decimal version of it, they actually went after the fraction version, which is what I would have done if I had really been in charge of the problem. And next, we're going to move on to dividing rational numbers. Keep, change, flip. Should be pretty easy. Two numbers whose products are 1 are called multiplicative inverses. I think we've defined that before, but if not, you probably need to write it down because you will see it again. It's also known as reciprocals. For example, -1/4 and -4 are multiplicative inverses because if you multiply them times each other, you get a +1. Now we're going to watch an animation about dividing rational numbers. Make it a little bit smaller here, not that small. And that looks good right there.
To divide by a rational number, rewrite the division as multiplication, multiplying by the reciprocal of the divisor. Then multiply. Use the product to identify the quotient. The division problem has the same result as the multiplication problem.
Well, alright, that was pretty dang exciting. In other words, what did they do? They keep, change, flip, and then treated it just like they would have any other fraction, or in this case it became two integers being multiplied by each other. Alright, so let's take a look. Divide rational numbers is the next topic we get to work on here. We just watched a video from the textbook on how to do it, and now we're going to walk through their instructions on doing one. They have -2/3 divided by +1/9, and the next thing they're going to show is that they did their keep, change, flip. They kept the -2/3, they changed division multiplication, and they flipped or took the reciprocal of the second number. From here, it's going to be simplified time. 3 went into 3 1 times, 3 went into 9 3 times, and from there we're going to take and multiply. 2 times 3 is going to be 3, 1 times 1 is going to be 1, and a negative times a positive is going to be a negative, so our final answer is going to give us a -3/1, also known as -3. Oh, nope, I missed that one, -6/1. I'm talking and not doing the math. -6/1, which is going to end up giving us -6 for our final answer. And now it's going to be your turn again. It should be pretty simple. Keep, change, flip. Pay attention to your signs. Easy math. Anybody can do this stuff. Just take a minute to pay attention to what it's asking you to do. 5/8 divided by -3/4. Go. So let's take a look here. We're going to keep the first number, 5 divided by 8, change division and multiplication, and flip or take the reciprocal of the second number, making it a 4/3. Next, I'm going to simplify. 4 goes into 8 2 times, 4 goes into 4 1 time, and I'm going to multiply. 5 times 1, that's going to be 5. 2 times 3, that's going to be 6. Positive times a negative, that's going to be negative for a -5/6 for my final answer, which I did circle. And we're going to type it in, a -5/6, and accept, and check. Answer checked. So cool. Well, it looks like the textbook's feeling kind of froggy. They have given you another problem to work, this one involving a whole number, an integer, and a mixed number that's negative. Pause the video, solve the problem, go. Did you work the problem? You need to work the problem. Don't sit there and pretend you work the problem and not work the problem. You need to work the problem. Alright, so I'm going to take and do it. -5/1 divided by 3 times 1 is 3 plus 1 is 4/3 is equal to. From there, we're going to take and keep, change, flip. Keep the first number, -5, change division multiplication, and flip or take the reciprocal of the second number, making it 3 over 4. Nothing's going to simplify in here. 3 times or 5 times 3 is going to become 15. 1 times 4 is going to be 4. A negative times a negative is going to be a positive. And our final answer, 4 goes into 15 3 times, with 3 left over, making that 3 3/4 for our final answer. Come back over here, plug that answer in. 3 3 over 4. Accept and check. Problem checks. Easy math. Now the textbook's going to tell us the same thing as told us for everything else, that if you are working with fractions that can be written as terminating decimals, meaning the denominator is divisible only by 2's and 5's, then you have options. You can change everything to a decimal and work it, or you can change everything to a fraction and work it. However, if you do not have something that can be written as terminating decimals, meaning that the denominator is divisible by something other than a 2 or a 5, then you have to work everything as a fraction. This is nothing new. It's the same thing that did for adding, for subtracting, and for multiplying, and now for dividing. And it's time to play a little bit more. Here we have a divided by b, where a is a fraction, which means we're going to have a fraction inside of a fraction. Fractions and fractions are scary things, but in the end, it really isn't that bad. So let's follow through the process and decide whether we're going to want to work it as a decimal or as a fraction. That's an important decision. Point out your fraction here. Your denominator is 4. Does that turn into a terminating decimal? Yes, it will, because 4 is just 2 times 2. So, method 1, evaluate the numbers as decimals is what they're going to look at first. So, they took the 3/4, and 3/4 became 0.75, so you had a positive 0.75 divided by a negative 0.05, and when they divide that out, well, let's take a minute and just go off and do a little scratch work on that, because I know long division is an issue for some of y'all. So I have 0.75 divided by 0.05, bounce, 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 bounce. 5 goes into 7 1 times. 1 times 5 is 5 with 2 left over. Bring down the 5, and it goes into 25 5 times, which is 25 with nothing left over. So first thing we know is that there's going to be a 15 involved there. But I also have to keep in mind I have a positive divided by a negative, so my final answer is going to be a negative 15. Accept and check. The answer checks. Now that's dividing it using decimals, but what if we want to divide it using fractions? That's where things are going to get interesting, because then we're going to have a fraction inside of a fraction, and it's scary, but in the end it's not really that big of a deal. So wow, look at all the work they put here. I think that I'm going to take and start off with a screenshot of the first part, and I'm going to work it out slowly by hand with you so you don't get overwhelmed by the problems. So are you ready? Let's take a look at this thing. First thing we need to do is we need to take and convert this 0.05 into a fraction. So my next line is going to say, whoops, let me get a marker here. In fact, I'm even going to do it up here on top. I'm going to have 3/4 on the top, and on the bottom this number is a negative 5/100. So that's going to be a negative 5 over 100. Now 5/100, that simplifies. So I can rewrite that to be 3 over 4 divided by 5/100 is also going to be 1/20, but don't forget your negative sign there. And now I've got what I need to work with here. 3/4 divided by 1/20, I can rewrite that as something that's a little bit more user-friendly for me using the vinculum, which is what we call this symbol here. 3/4 divided by a negative 1/20. From here, we're going to keep change flip. 3 divided by 4, change division multiplication, and take the reciprocal of the second number. Simplify, which means 4 goes into 4 once, 4 goes into 25 times, and multiply. 3 times 5, that's going to be 15. I really thought I grabbed blue. 1 times 1 is 1. Positive times a negative is a negative. So a negative 15 is going to be our final answer. Come back over here, and what do they get? Let's put it in, negative 15, and check. Our answer checks just like theirs did. It probably wouldn't be a bad idea for you to take and write down all of these notes here on how they did it, but in the end, what would good supporting work look like? It looked like that. Mine's a lot more concise than what they did. Alright, now it's going to be your turn to show me that you know how to divide a fraction in a fraction, or a fraction by a decimal, or a mixed number by a decimal with a whole number and a decimal value in it. That ought to be really exciting. Pause the video. You've got to start off with it as being x over y. Work the problem, and let's check our answers. So, what do we have going on here? We're going to start off with, let's get our marker going, go back to the color prettier than black. I have x divided by y, which is, my x is a negative 6 3/8 divided by the y is a negative 4.25. Now those two numbers, I think we're going to just work as fractions, because you know what? I like fractions. Fractions are our friends. Decimals, no. I hate working with decimals. So the 6 3/8, I'm just going to leave alone for a minute. So that's going to stay up top as a 6 3/8. And the bottom, I'm going to change to a negative 4 1/4, because 0.25 is the same thing as 1/4. Now it's time to change them to improper fractions. 8 times 6, that one always gives me trouble, because 8 times 7 is 42. So 6 times 7 is 42. 6 times 8 is going to end up being 48. Oh, no, not 48. 48 plus 3 is going to be 51 over 8. Of course, that's going to be a negative number. And on the bottom, 4 times 4 is 16, plus 1 is 15 over 4. And that's going to be a negative number as well. And now we're in a position to go and write it as something that looks a whole lot less scary than this mess. So I'm going to rewrite it using the vinculum, negative 15 divided by 8 divided by a negative 15 divided by 4. And I think I said 15 here, that's actually 51. Next we're going to keep change flip, negative 51 over 8 times a negative 4 over 15 is equal to, we're going to simplify, 4 goes into 4 once, 4 goes into 8 2 times, and is anything else going to simplify? Yes, it will, because 5 plus 1 is equal to 6. I know that that's divisible by 3. 1 plus 5 is equal to 6. I know that's divisible by 3. This one's easy. 3 goes into 15 5 times. Here, 3 goes into 51 17 times, I believe. Yep, 17 times. Now we've done all the simplifying we can do. We're going to multiply. 17 times 1 is 17. 2 times 5 is 10, and then a negative times a negative is a positive, so our final answer is going to become 1 7/10, which is a positive. We're going to come back over to our problem, plug it in, 1 7/10, accept and check. Why is it saying that I'm wrong? Let's see here, 2/3. That don't make any sense, because we don't write problems in improper fractions. But let me check it again. I totally found my problem. My problem came from running my mouth instead of doing my math. And it exists right here to here. What's 4 times 4? 16 plus 1, 17. What did I say it was? I said it was 15. Now I'm not going to go back and rework the whole problem for you with a different number, because the way I showed it is going to teach you what to do. I just put the wrong number in, so I'm not going to make you watch it all again. And I think we're going to skip the apply problem on this one. They're a little vague in how they ask the question, and I think we have spent more than enough time working these problems. We don't need to dig in any deeper. Y'all get started on your homework. Good luck. I look forward to answering any questions you might have tomorrow in class.